how many people that are on right now have done any sort of Go development. There's a little emoji at the bottom. You can raise your hand.
Thanks, VF.
I'm gonna assume not a lot. Okay, I see one person. All right, so a couple of you have played around with it. That's good. So what I would like to do is I want to start off by just kind of going over the language itself really quickly. So I have about 40 minutes to do the whole thing. So I'm not going to spend a whole lot of time on the actual presentation, but I do want us to kind of look at it to get familiar with the syntax and the code before I show you the actual code, just so you are familiar with what those things are on the screen. So I'm gonna go ahead and get started with my screen here.
Perfect. And once again, I just want to do a quick reminder. This is going to be a recorded event. Okay, so I'll go ahead and begin recording at this time. So if you'd like to disable your camera, feel free to do so at this time. Thank you.
All right, so let's move some stuff around on my setup here. No, not this one. So, like I said, my name is Hussein Abbasi. I am the head of technology at Chai One. Um, that's my Twitter handle. That's the best place to find me or see what I'm up to. So that's why I usually start with that. So it's my name with an extra N in the middle. Um, so what is Chai One? Chai One is a digital consulting company. We work with a lot of industrial customers for their software needs, and we build a lot of custom application in JavaScript, front-end technologies, .NET, Ruby on Rails. So we have a whole wide tech stack that we use, and Go is kind of new to us. We started working in that this year, so that's also part of our story now. So if you are what we do, what is our differentiator is really our strength with users research and design. So what we do is we are very user centric. So our behavioral scientists are the one who go out, talk to the customers, get all the data we need to build a system that gets adopted and used. Then our awesome design team goes out and designs those systems, and then the developers do their thing. And then we have data science that helps the customers as well with what to do once the app is live, and like what to do with the data, how the adoption is going, etc. So we are hiring. We're always hiring. So if you are someone who is in a project management role, in a user research, user design, developer, even data scientists, we like just whatever I can tickle your fancy. We are hiring. So reach out to me directly or go to that link at the bottom and see what we have open for you. Enough of that really quickly. Today's agenda is going to be we'll talk about the basics, we'll talk about the advanced, at least I call them advanced. Then we will see how we can actually use Go within your browser without having to make that server round trip. And then we will look at the actual APIs that are available that I built and how they all work. And now I have a thing that says how to deploy to Azure. It's similar to how you would deploy to AWS or GCP, for instance. I'm not going to go into that too much. We'll just kind of touch on that, and then we'll talk about some of the resources that we can get if you are getting started. Right? Okay, so what is Go? Go is an open source programming language that enables you to build simple, clean, and lightweight well, production apps based on using the simple syntax that comes with Go, and it's a very lightweight language that we'll see in a second, right? Um, how does it work? It compiles into your native platform, so it's cross-compiled. So when you run the app, based on if you are on Linux, Mac, Windows, on x86 architecture or ARM, you will be able to cross compile your code into that, including WASM, right? And I'll talk about that when I get to it. So who's using Go? Because Go has picked up steam in the last year or so. A lot of people are talking about it. Well, it's been around for a while, and a lot of these companies are already using it. Matter of fact, Docker is built on Go. You may know that, or you may not know that. and also some of the other databases are built using Go technology as well. So like I mentioned, it cross-compiles into the native platform to give you that performance. And some of the best use cases or the most used use cases for Go are networking, DevOps, web development, and CLI as well, right? So a lot of the DevOps side of the development world is very comfortable with Go and is heavily using Go. Okay, enough with that. Let's jump into the basics. So Go supports all the primitive types that you would imagine. It has ints, signed and unsigned ints, has floats, Boolean string, rune, which is a Unicode representation, and a byte. So that's it, right? It doesn't have a whole lot of more list because it's a very small, lightweight language. So you will see it doesn't have a lot of bells and whistles that some of the other languages have. It does support data structures like arrays and slices. So we'll talk about those. It has a map, struct, and interface. So interface is for you JavaScript developers is like any, right? So you can essentially have an empty interface and it could return whatever you want it to return. Logic controller has if, for, and switch. The for range loop is my favorite, and you will see why. And the switch is a little different in Go than it is in some of the other languages. So I come from a .NET background, so even though I did all the other languages that I mentioned earlier, I've been mainly in .NET, so C Sharp, and a little bit of VB long time ago. So for me, for range loop is some of the things that I kind of compare back to my C and C Sharp and Java world. So I get very excited with this because it's a simpler, cleaner variant of what I have in those two languages. All right, so let's get started with some of the syntax. I believe I've done this on virtual a few times, and I believe this works just fine. If you get any sort of issue viewing the screen, let me know, and we can try it. But I think you should be able to read it just fine. So how do you initialize variable? You start with the word var, name the variable, and then the type. And the type is string, lowercase, right? This is just if you want to declare and initialize later. You can also initialize it while you declare it. But one of the most used way of doing this, of initializing variables, you will see in sample code and everywhere else, looks like this, where you declare and initialize at the same time. So it's the simplified version of it. There is also a throwaway that I call it throwaway. I don't know what the technical term is. I just call it throwaway variable, which is an underscore. So if you have done any sort of development in Swift, you would know that if you are using underscore, you don't want that memory address, you don't care about it, just read it and throw it away. Go has the same concept. So you can read what's in the underscore once you assign it. So it's usually good to throw away variables that you don't care about. Functions and method, not too crazy. So you start with the func, then you name the method, or you can have anonymous, the second one. Or if you have a name, the return type comes after the parameters or the declaration. And you can actually tie these functions to a type by getting the type in. And then in this case, you can see that if I'm saying person, the last one, the get person method is only applicable to the type person and nothing else. And at the same time, you can return more than one return type. So in this case, I'm returning two variables, a person type and an error type. Remember, I had the underscore to throw one of them away if I needed to. And then, of course, it has the array where you can just pass in as many parameters as you want. Like I mentioned earlier, methods, functions and methods, we can tie them to type by just making sure that we mention the type before the name of the function. So in this case, you can see I'm saying that a get full name and get age only is tied to the type that is of type person. Arrays and slices. A slice is just a projection of an array. What that means is there's still an array behind that slice, but you don't have to worry about sizing it and doing all that stuff. I don't want to make the comparison, but if you need to connect it to some other languages, let's say in Java, it's kind of like an array list where you don't have to worry about the underlying array. You just work with the list and it takes care of everything else. So that's what this one is doing. So in this case, let's just say if I initialize a slice of integers, so the square brackets come before the type, and then I just initialize it with 3 value. And if I use the built-in length function to see what the length of my collection is, it'll print out 3. But if I wanted to actually turn this thing into an array, all I have to do is give it the size. Once I give it a size, as you can see, I gave it a size of 5. Now I'm dealing with the actual array that's behind the slice and not the actual slice anymore. And now if I print the length of array, you see that it actually didn't only stop at the 3 values I provided. It filled up the other with the default values because that's what I told it to do. And now if I tell it, if I ask for a length, I get the whole 5 back. So it's pretty neat. Maps, as you would imagine, the syntax is a little off the first time you look at it. So you have the word keyword map, and then you have the key within the bracket and the value right next to it. But once you look at it, it'll get easier. So you can see I have a map of strings and integers, and you can see it's just pretty easy to look at that. So Go doesn't have inheritance, the concept of inheritance, right? Because it's composition model. What does that mean? So let's just say we have so anytime you want to create a object, it's actually type in Go. We can just use it like type, name of the type, struct, and then just structure it. The difference is that you may see that sometimes it's an uppercase variable, sometimes they're lowercase, right? So in Go, everything is scoped to a package. So if you want anything to be exported out of the package, you will start the first letter of that variable function method with the uppercase. And if you want it to not be exported and stay within the scope of that package, you just stay lowercase. So in this case, you can see vehicle and its 2 properties will be exported out to the package, and we'll see what that means. Now, we can have nested structs. So in this case, I have a type vehicle, and then I have a type category, which I just declared within the struct, and it works just perfectly fine. Now, there is a concept of something called tag. A tag is usually used for encoding and decoding. In this case, you can see I'm using it for serializing and deserializing JSON. So I bring in the JSON library, and I just say vehicle struct, and now I'm giving it a tag. What the tag does, as you would imagine, is when I'm serializing, deserializing, marshalling, unmarshalling JSON to this type, is going to use those JSON names for creating those, or serializing and deserializing. And that's all it's doing here, that, okay, my make will be lowercase make, my model will be that, etc. Okay, so I talked about no inheritance. So how does that work? So in this case, we have a vehicle and then we have a car, and car is a vehicle. So instead of having a car struct extends or something like this, we just embed the vehicle type within the car type. So I have a vehicle that has make and model. I have a car that is of type vehicle, so I'm going to put that vehicle in there, and then I have an extra property called speed. And when I'm working with initializing that type, all I have to do is either the top or the bottom. I can say a car is a new car object that has a new vehicle object inside it that is make and model, and then the speed. Or if I remove the parameter names, then it's just one liner at the bottom. You can see that it's a car that has a vehicle object inside it or type, and then has a speed, right? So that's how we would embed one type into another type, as we see. Interfaces. So I know it's switching between black and white, but bear with me. This is by design. So an interface in Go, interface just defines a behavior. Any type that has that behavior will implement that interface. Right? For instance, let's just say we have an interface called drivable, and we have an interface called flyable. And drivable has a drive method, flyable has a fly method, and we have a few types: car that can drive, truck that can drive, a vehicle that can do both, and a plane that can only fly. So as long as I have a matching implementation to an interface, I can use that type for my interface. And I hope it makes sense. If not, then you will see it as we go through. So imagine we have a interface called shape, and it has a method called area, right? And then at the bottom, I'm expecting a shape to be passed into this method called print area, and I'm just saying s.area. Now, what I'm passing into that method, if you look, I'm passing in a circle and a square. So I can have a circle type, a square type. They both will have an area method, And because that signature matches the interface, I can pass them into a shape interface because they also have the same signature, which is pretty cool. Talked about this, so let's not jump to too much. This is recorded, so you can always go back, pause it, and see what the code is, but you will see the code in a better way. And this is just talking about interfaces, how we can pass in interfaces. Now, the if control. So as you would imagine, it's just an if condition, do something. And if you have, one of the things that it's interesting in Go is that we can actually initialize and declare and initialize variables within that if statement and then check for them. So in this case, we have a second one, we have a foo method that returns some value. So I'm saying if val colon equals, get the value, and then right away check if the value is null or not. And if it is not null, then do something with it. Right? So, and whenever I do this though, it is scoped to my if else block. So for instance, in this case, that val variable is not available to me outside of that if. Right? So if I do if else, it'll be available to me throughout that if else block, but once I'm done with it, that variable is not available to me. There is something called an if okay pattern, which essentially, as you can see here, is used to just see run an if and check for a condition before moving on. So okay just means, is it okay for me to move on? Does this value exist in this collection? So one of the good use cases at the end, at the bottom, you see is when you are checking for a key in a map, you can just say, give me the value, comma, and okay, which means if the key exists in that map, it'll return true, otherwise it'll return false. So I can just check, did the key even exist? So it won't explode, or it won't throw an exception or panic to say, hey, this key doesn't exist, or this key doesn't exist, crash the app. It'll just return a false that this key didn't exist, do something else. So it's pretty cool. It's an easy way to do it. The for condition, it's pretty straightforward. Like I was telling you earlier, so all the do, while do, and all that kind of is condensed into a single for loop here. So we have a for with a condition. We have an infinite loop where you can just say a for. When you don't give it any condition, that means it's true. So it'll be infinite loop until you break out of it. And then a conditional, which is for, if it's true, do the thing. And to break out of a loop, if you're in an infinite loop, you will just use a break keyword or a continue keyword, like you would imagine. For range. So for range, as I mentioned earlier, it's pretty cool where you can actually iterate through a range and it gets you back a few things. So if it's an array or a slice, you can do for index, comma, value, assign range, ARR, which is our collection, and it will return the index and the value at that index, which is pretty cool. So think of it as for each and for combined into one, which is pretty neat. So it does wonders on collections, especially with the range. So you can see it's doing that there, but you can also use it on a map. So you can say key value and then print that out, and it's pretty neat. So for range is one of my favorite. Switch, this is the last thing I'll talk about, then we'll jump through a few more things. So switch, as you would imagine, doesn't require a constant, so you can actually have conditions in your switch. So in this case, you can see I'm checking for the day in my case. So instead of doing it before or beforehand and coming and checking a constant value, I can do conditions. And there's one more weird trick in switch in Go, which is, imagine you had a ticketing system where if you passed in a state to a method, and based on the state, you want to assign or print a message. Sorry, you want to say the task was created, the task was resolved, or the task was closed. So this works perfectly fine. But what if you wanted to do two conditions, or if you wanted to come down the tree and then do all the subsequent conditions once the first condition is met? Well, in Go, there is something called a fall through. Fall through essentially just tells the control that after this, right away execute the next block without checking the condition. So what this would print is, if I passed in a closed, it will only print closed, but if I pass in a resolve, it will print resolved and it will print closed because I told it to fall through to the next case. And if I go crazy and I put fall through in all the cases, then they will all be printed no matter what. Right? Or after the first one is true, it'll print out the rest of them as well. So I'm sure there's a use case for it. I just can't think of a good one. Code structures. So Go has this concept of modules, and modules have packages. And if you remember when I was talking about exporting something out of a package versus scoping within the package, this is what I was talking about. So imagine if you have a package called models, and then you have a model inside it called person. If that person is with a lowercase p, it will not be visible to anyone else. So if you see a models dot, it will not show up. But if you want to export that, you will say capital P person, so it will show up here. So we can have multiple modules in our code, and modules can have multiple packages, and then they can interact accordingly. In an advance, how are we doing on time? So far, so good. I'm going to run through some of these examples because I want to show you the code. So there's a concept of generics where we can give it some types for doing any kind of calculation. For instance, in this case, we can define our own interface with multiple types and then use that interface for our generics, right? And the biggest thing or the most talked about thing in Go is the Go routine. Its ability to have concurrency. So a Go routine is not a OS level thread. It's actually a user level thread. So think of it as a really lightweight thread that just spins up on your user thread and it doesn't go down to the OS thread all the way, which means it doesn't have to worry about the performance hit that you may get if you're using the underlying OS thread. What are Go routines? Any function you run could be turned into Go routine by just appending the Go word in front of it. And then you can also, in some cases, you will find that you can also spin up a anonymous function as a Go routine and then do something inside of that. Every main function that gets executed is actually a Go routine behind the scenes as well. Right? So how will you use Go routines? So Go routines are more of a fire and forget kind of feature. You don't want it to you don't get a value back from, so you won't have a return from the Go method if you're trying to do that. However, yeah, you can put a wait group around it to say I'm going to spin up 10 Go routines and I care about all of them finishing. So you can put a wait group and say, hey, wait group, I'm going to add X amount of Go routines and I want you to wait for all of them. Now, because Go lets you make this decision for yourself, if you give it more numbers, if the numbers don't match, then your app will hang because it'll just wait for the let's just say 3 workers, but you only spun up 2. It's gonna say I'm waiting for the third one, and if it's not there, your app will just not work. So what happens? We can start a wait group, and then within each wait group, when we're done with the function, we can call it. We can let the wait group know that I'm done working. So you just call in the .done method, and at the bottom you can see I'm saying wait for all of them. So I'm waiting for all of them to finish before I move on to my execution. Right. So we'll see that in action in the API. Now, if Go routines are fire and forget, how do you actually communicate between them, right? Because they're not supposed Go routines don't know about each other, right? Well, they use channels for that, and channels are single type. They are buffered and unbuffered channels, and they are very easy to work with as well. So to work with the channel, you create the channel first using the chan keyword and giving it a type. So like I said, a single type, so you can mix types in a channel. To send information to a channel, we just use that arrow dash notation. And to get information out of channel, you would imagine you will just flip the arrow, but no, you actually flip the placement of the variable in the channel because the arrows will stay the same, right? So in this case, I'm sending a 1 to this channel C somewhere in one of my Go routines, and someone else is waiting for that value. So they get that value and then they assign it to the variable I and they do something with it. Right? So that's how the Go routines communicates. In this case, you can see I'm spinning up a whole new Go routine and I'm sending in so in this Go routine, right, I have an anonymous function that takes in a channel. I pass in my channel, and then that function at some point sends in a 10 to that channel, and I get it back in my main function because I'm listening for it. Now, channels are kind of tricky at first to get used to, but once you get used to them, they're very powerful. You cannot send if your channel is not buffered, you can only send one at a time and read one at a time. But if you try to send it to a channel more than once, if it's not buffered, it will panic because it wouldn't know what to do. So to buffer a channel, we just give it a size, and you can give it a size of 1. It'll still be okay. So that's channels. Like I mentioned, they're single type. Now, I will run through this. There is a repository on my GitHub that will show you how you can actually use Go in your browser. And the idea is Go has this built-in syscall library that has JavaScript built in. So we can take our Go code, crosswalk it, and match it with the names to JavaScript names in the browser. Run it, it will give us a WASM file, and then run it in the browser using the WASM execute helper. All that is in the thing. So I'll just run through this. Essentially what you will get is something like this. So I built a Fibonacci calculator in the browser that uses a JavaScript way of calculating a pure WebAssembly code and Go code. And I wrote all three, which is a lot of fun. And then there's the repositories at the bottom, so you can see that. Building REST in Go. Whew. So came a long way. Let's see if we can look at some code now. So when I do this in person, I use light theme because it's easy to read. But on your screen, I'm sure you're able to read this. If you're not, let me know. But I'm sure, Leo, you can let me know if it's legible.
Yep, legible.
Cool. So this is Go. As I mentioned before, this is an API that I want to show you how it works and what it does. How about we do that first so you know what you're looking for. So I built an API. It is, let's go ahead and run it now. I don't want to go elsewhere. Let's go ahead and run this. You will see that it's running a local version at 8080. So let's go to localhost 8080. It'll say nothing found because there's nothing there. You will see this is my API. It says welcome to Sam's Weather API. Right, it's pretty awesome. I can come in here and say, show me all the alerts for a given state. And because we know Florida is having a lot of activity, if you go to the browser and say /alert/ the state code, it will come back with the list of alerts. So it's telling me there are currently 84 active alerts for that whole state. And these are just the details of that alert. Right? So it's coming from my Go, and you can see down here that I called /API, and I called /Florida, right? And the same thing will go for California, because I know there are some people from California. You guys have 3 right now, so you know that's safe. So what is going on here? So this is my code structure. Let me show you that. All right. I hope you can see this well. So you see I have a source directory, I have a build directory, and then I currently have just one deployment, which is Azure Functions. So you have a separate directory. But if we go to source, you see that I have this thing in red called main. I'm actually gonna go ahead and remove that. So you see no main. So now all we have is the actual code. And for those of you thinking, wait, how is he getting this ls command to look so properly formatted? Because I'm using ll, not ls, because ls is pretty ugly. So if you do ll, at least on a Mac, you'll get it in a list format. If you do la, it'll show you all, including the hidden ones. So just a little Mac lesson. So here you see I have a Go mod file, which is the module I was talking about. I only have one right now. Then I have my Go file, ignore the make file. I have models folder, services folder, and handlers folder, right? So we can see it on this side. We have source, handlers, models, and this. So I'm using in my case, I'm using a library called Gin, which is a web framework used for building REST APIs in Go. It just makes it very easy to work with that. So you don't have to worry about the HTTP response itself. However, you don't need to use a framework. The HTTP package itself has all the capabilities we need to run that command. So I think this is much better. So here you can see I'm doing something like import FMT, import log. Right? Instead of having a bunch of imports, we can just put them all in a single line and just wrap them with the parentheses. There are no semicolons, as you can see. So I'm bringing in a few packages here, and then I'm bringing in a GitHub package here. And then I'm using my own handlers package, which you will see, which is this package up here. So what I'm doing is initially in my main function, which is my entry point, I just have a method that says setup startup server. Now, this is how I usually have it, right? That all you see is an Eden sorry, used to this, sorry. Just a little method, but because I'm actually on Golang, which is an IDE by JetBrains, you don't have to be, you can do this in Visual Studio Code. I just happen to have the whole IDE, so I like this one because it does this. It's like, wait, I know you did this, but did you know you are actually not doing X, Y, Z? So I'm like, okay, you know what? That's a good idea. So let's go ahead and make sure we don't miss any errors. So that's where that is coming from. So, but all it's doing is setting up a server. So the router type is coming from Gen. I'm saying get the default router type, set up my routes. Now there are two ways to do the routes. There is inline. So I'm showing you this as an example. I can do /API that will return a function that takes in a context and returns in a JSON as a response, right? So I'm passing in, or I'm responding with the status okay, and then the text that you guys saw when we were in there that said things API. And but then for my /alerts and /weather, I have other handlers. So in this case, I have two APIs. We'll talk about both, but we'll talk about this first. So it's just an alert API that takes in a variable query path string called state, and we call get alerts for state. Now, if I go back to my handlers, if I go to alert handler, this is that handler that we were looking at. Get alerts for state that returns a function for the actual library. So it takes in so I'm returning for that one, I'm returning just a function because I'm passing back a handler. So you may have seen that I'm actually using the extra, so this is the function, but I'm actually executing it here. This helps with testing, so we can actually test what the response comes back as a function. So I'm responding with a function as opposed to just returning the value. So all I'm doing here is I'm using yet another package called services, and I can name my package services. And I'm calling in a service to actually call the response and get the response for me. And I'm looking for a parameter in my context of the name state. So when I passed in FL, this is how I passed it in. And if you notice that if OK pattern is in use here, so I'm saying if alerts are, give me the alerts back and look for any errors. If there are no errors, which means I'm good, go ahead and well, if the error is not nil, sorry, respond with a bad request and then throw some generic message. Again, it's not the best practice. This is just for playing, so don't worry too much about this. Otherwise, status send back status okay and send back the result, and the result will be formatted into JSON, which is pretty neat. Same thing for my weather handler, which is a little bit more involved. So in this one, I have a get weather that passes in the state, city, and state, does the same exact thing. So the handlers are pretty light, they're not doing much. Let's go to the service. And if we go to the alert service, we have the get alert function. We have some base URL and some other things going on. I have environment variables for my API that I'm hitting. And then there's an alert. So here you can see I have a URL that's just a string concatenation. Then I'm doing response or error. I'm using a generic method here called get response. It's pretty clean. As you can see, all I have to do is just use my HTTP package, which is up here, which is right here, net HTTP, and pass in a URL. So all I'm saying is get this URL. If everything was not fine, then return if everything. So in this case, you can see I'm returning either a byte array or an error. So if I'm using, if there is an error, then I'm going to return a nil and the error itself. Otherwise, I'm going to use something called defer. Now, I didn't talk about this, but defer in Go means, so I can do this essentially, it's defer body, what was it called? Defer body.close. Sorry, response.body.close. So what this does is defer means defer this execution until the end of this code block. So when I say defer body close, I'm just telling Go that when you get here at the bottom and you're done with everything else, make sure you run this before you return to your caller, right? And because this close can also fail, I just have a func around this to make sure if the closing of that fails. But essentially, that's what it is, right? I know it starts to get more complicated the more it throws in, but essentially, that's all we are doing is trying to close the response body, and if something fails, just report it. In this case, I don't really care about that, so I'm just logging it. But in case you were looking for that, you may want to do something else. Here, we just look for, we read the body of that response into a body type, and then we just say if the status code was not good, then go ahead and return that. If status code was good, then return that body back to the caller, which is the HTTP response. Now, what I do with that is, since it's just a JSON, right? It comes to me in this response, and then I don't want to go to my models and create a whole different model just to get these two types in. So what I'm doing is the response I actually get back from, so I'm using National Weather Service. I'm using National Weather Service APIs to get this. So you can see um, this is the kind of response that comes back from there, which is very heavy, very busy, and I don't want all of this stuff. What I want is when you call my alerts, it will tell you when it was updated, how many counts, so you know how many alerts are coming in, and just an alert array. So a simpler, cleaner version of that API. So I take all this and I just want to return updated count and alerts. So in my Go, I create a inline struct. So I'm creating a new type within inline, kind of like private class. And I'm saying there will be an update property, which will be updated, and then there will be an alerts property that incoming will be called features, because we saw that it was called features here, right? Features, and get the response marshal. Marshal and unmarshal is like deserialized. So created this inline struct, used the address of that struct to unmarshal the JSON. If everything went well, then create a, so in my models package, I have an alert response, pass these values in, and then just return that as the return type for my alerts. Now, let's look at the models really quick. So if we go into models, uh, so Go likes to keep everything in one place. So best practices, I should have all my alerts model with my alert services and not in a whole different place called models, unless they are being used by multiple packages, which in my case they are. So I put them in the models folder, but I didn't have to, right? So I have an alert model. You can see it's just a struct. I have an ID here, and then this is pretty cool. I have a properties type that has a bunch of these types within. They all have their names as well. And if you notice, if you have to do something crazy like this where you are nesting JSONs, you can pretty easily do that here. So I have property that has all these types, that has this type, that further has geometry type, right? So you can just nest all the way you want to. And the funny or the good part, like I was mentioning earlier, is this is where I'm saying make location response. Oh, not this one, sorry. This one here, get weather string, is only applied to a period type, so you cannot call this on any other. And I want to show you the alerts response. So this is the big response that I'll show you in a second, which is called weather response. And in here, we have the alert response, right? And alert response looks just like what we saw on the browser. We have an updated property, account property, and alerts property, which is just an area of alerts. Now, I want the same in my other response. So for instance, well, let me run this again. Okay, we are running. The other API I have, if I go to localhost, I can say weather, and now I can give it a name of a city. So I can say Houston, and it does a few things. It goes out to ArcGIS to get the actual coordinates for that city name, and then it presents that. So now you see in my city, I'm bringing in about 10 different APIs in a single place, which is pretty neat. And this is the response for my weather response. So I have updated ID, but then in here I have something called active alerts right here. And active alerts are for that state that I'm in. And if you notice, this is the same exact object as the alerts response, which is updated count and alerts, which is right here, updated count and alerts. And I'm able to do that by simply putting an alert response type, embedding that type into my weather response right here. and calling it active alerts. Right? So it's pretty neat. I call it active alerts just so not every alert will be active. Otherwise, you get an empty array. So whatever. So my weather response gets an updated property, then it gets a location response, which is that whole piece that comes in. Then there's an alert response, and there's some observation, then hourly, et cetera, and you see all this here. And this is my big weather response. So when I call this method function, it does all that stuff and it returns either the response or an error, and then we go about it. Now, this is pretty simple because it's not really doing much. But if we look at the weather handler, sorry, the weather service, this is pretty involved because, as you would imagine, it's doing a few things, right? So if I say get weather for a city, there are two things I cannot do in parallel because they depend on one another. So what I'm going to do is I'm going to start my response. I'm going to start a wait group. But first, I need the coordinates. So I'm not going to spin up any Go routine or anything. I could, but I don't have to. Best practices, if you can do it yourself, do it yourself. So in here, I'm calling in a method called getCity, passing in a city state, getting back coordinates. If I don't get coordinates back, I return an error. If I do get the coordinates back, now I want to get the location. And if I don't get the location, again, I error out. If I do get the location, then everything else, I don't care about the errors anymore, right? So imagine if you look for, give me a weather for Tampa, Florida. You want to be able to get the coordinates in the city, and then you may not get hourly rain chances or weekly rain chances, but everything else comes back, you want that back, right? So you don't want to crash the whole response because something didn't come back. So once I get the coordinates and once I get the location from the coordinates, now I'm telling wait group that I'm about to spin up 6 concurrent processes. And what I want you to do is run them all, and I'm passing in address. Remember when I said you couldn't return a value from a Go routine? But what you could do is you can pass in an address to your variable or your type, and it will just update that type without returning anything. And if you look at this, that's exactly what's going on. I'm passing in an address to my wait group and an address to my weather response, and it's doing its thing, and then it's saying, okay, update my weather response, do whatever I need to, and then just call wait group.done. So what my response does is these two are blocking calls, and then these 6 are not. So they all go out in their own way, and when we wait for all of them to come back home, when they come back, then we return the response, right? So it's pretty straightforward. This code is available on GitHub, so you just go through it, as much as you want. Play around with it. You will see it's pretty neat. There are some neat tricks that I'm doing for filling in the daily or the hourly rain chances. So it's a lot of code. You don't need to again worry about it a whole lot, but do go to GitHub and see it. And then when this code runs, you get this method. And if we go to, am I running it? Yes, I'm running it. If you go here, you will see that I called weather dash Houston. We can also call any other city, and it does the same thing. I think it's still running. Yeah. And if I go back, you will see that I called Houston, I called Austin, and it does that, right? So this is the API, right? Now, why do I have the AZ function? So AZ func is Azure function that I'm using to deploy these to my Azure function. So for example, these are all localhost, and I can go to my Azure function that I've deployed and look for the alerts again, and you see that I get the same result for this is deployed version of this app that you're looking at right now. That's there. So feel free to plug in your city and your state to this, and then just play with that and see what you get back. This is great. So when I'm building my talks on front ends, I use this API to show results in that. It's pretty cool. So in my Azure function, what I'm doing is I have the functions that I need. So for instance, here I have the alerts.state route function bindings, or all my Azure function bindings are here, and a weather, right? So when I'm ready, what I do is, so again, if we come in here, you see there is no file, but what I can do, I can say go build main.go. And if I run now, you'll see there's a red main, which is my executable, right? So I want to delete that. Oops. It won't be fun if I delete the whole thing. So if I delete that, now you see that that's gone. So now to cross compile my app, I have to do something like this. I will say Go OS is, let's just say Linux. Go architecture is AMD 64. And I can say Go build main.go, right? And if I run it, now it's actually going to build it for the OS and the architecture that I'm telling it to build, as opposed to where what my local environment is. And if I run it now, you see I still get main. I'll still be able to run it, but I'm not going to do that. Or should I do that? Let's see. Can I run main? I don't think I can run it like this. Oh, forget I did that. So we have that now. If I wanted to, what I could do is I could run that command again, and I can say that I want you to build me this method, and then I want to do an output. So I'm going to say output this to the folder called AZ functions and call it API. And now if I hit enter, if I run, this main is from before, but if I go back to my AZ function and I run, you see there's an API binder, or the API executable that's there. So once I do this, now I can go into my, now I can actually do something like func, Azure, function app, yada, 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 publish API, and it will publish it to my thing. Okay, so how did that work? Let's take a look at that really quick. Okay. So we looked at that, deploying to Azure. So we can do it either through CLI, that like I was about to show you, or we can do it using the GitHub action that I'll actually show you next, because that makes more sense. CLI, we will do some creation of resources, and this goes same thing for GCP or AWS as well, with of course different services. And here, this is the command I was telling you about, that we can give it the operating system, the architecture, and the output where it needs to go, and the file that we are building, right? And then I can just publish it by using my CLI. If not, then I can have GitHub action, and I'll show you that in a minute, so I don't want to spend too much time. When you've deployed, it should just show up like that. Before we do our recap, let's actually take a look at this. So if you go to GitHub, if you go to my thing, you'll see my face. If we go to, it's called Go WX API, WX stands for weather. If we go in here, if you go to workflows, I have two workflows here. One is to build, so every PR gets a build, and one is for publish. So let's look at publish, because build is the same. So it has two jobs. It has a build job and a publish job, and you can see I have OS as Linux, architecture, output path, and artifact name. I have a build that will do the same thing like we just looked at. It will build it. Oops. It will build it for you, and then you come down, upload, test, run all the tests, and then there's a publish, which is here. But for publish, I'm doing the same thing. I'm doing some CLI work, but there's a built-in action for me to upload. So I can either use CLI, or I can use a built-in action to upload to my Azure function, and then just log out of Azure. So when I do this, it automatically pushes it to my to the Azure function in the cloud. So it's on Azure, I mean. So it's all automated at this point. So now when I'm pushing in any change, the whole workflow is automated. Okay, so let's finish up the PowerPoint. So quick recap. Why use Go? Well, like we saw, it's cross-platform, so your web, cloud, CLI, more. The dev experience is very easy to learn. At least it was easy to learn for me in the beginning. And then the more advanced you get, the better, or some of the challenges show up. It is more performant than your JavaScript. So if you are a Primeagen follower, I recommend you do on Facebook and Twitch. He does a lot of comparison with Go and Rust and Node, and Go's performance is very close or closer to Rust, but they're both way more performant than Node at this point. And last year, when we had a survey, right, and like I said, it picked up steam last year. Well, the Stack Overflow survey, which some people don't care about, but that's one metric I look at. It was one of the top languages that people wanted to learn, and it's still there, right? And if you go to like if you're looking to see if can I be a good developer and make some money in this language, absolutely. It's a little bit more in demand than Rust just because of the use case. So it's definitely something for us to look at and get deeper in. Some of the resources, if you want to take a screenshot, this is the screen you want to take a screenshot of. So getting started, just go to go.dev. There's a /play. There's a playground. You can actually write code there and play with it. I have put together a snippet of all the codes that I was showing today in the tinyurl /go snippets, and I'll show you that in a second as well. The two the two GitHub repositories that I talked about for either browser Wasm or the Go weather, that's there right there for you to go play with. And the easiest, like I mentioned earlier, the easiest way to find me is on Twitter, which is my handle on the right side. But you can also find me on LinkedIn and GitHub with that handle on the left side, right? So before we call it a day, let's just look at a few more things. So I'm just going to show you wrong browser. So if I go to tinyurl, go to Go snippets, you will get to this gist, which is essentially a quick learning. So you will learn about variables, arrays, map, loop. This is all me learning Go last year or earlier this year. So you can get all this, play with it in your own time. And then you will see this is actually more useful example than I showed in the PowerPoint, which is for an area, we can have a square and a circle. Square has height and width, circle only has a radius. The way of calculating areas is very different, but since they are both shape and they both have areas, we can pass them in to a shape and get the value. It's pretty neat. So this is that, and if you go to go.dev, and if you go to /play, you can actually run your code and play with it here. And get some practice here if you want to before installing Go and all that good stuff. That is it.
Sweet.
I want to open it up for Q&A. And I want to thank everyone who stuck around to this point.
Absolutely. And guys, give it up. Guys, show some love. Thank you very much, Hussein. Okay, it's been a wonderful talk. I guess I'm a full stack developer. I don't use Go on my day to day. I use a different stack, and I'm just trying to see what other use case I could do that. Okay. You stated that this could be used for web development. Have you built anything that we can see and probably that you can put in the chat, okay, for web development besides an API that we might have a sample of, or probably a site that we can reference?
Yeah, so I would not use this for a front end right now. So there is a very powerful templating engine that Go has, where we can use templates to kind of like PHP, where you can have your Go code that has templates, curly braces, and you can drop in HTML tags all over the place. But I wouldn't replace my React application with Go for the front end. When I said web development, I was talking more for the API side of things. So if that'll be for instance, if you are one of our customers who came to us who was interested in Go, had an LMS system, and they were having some performance issues with their current ecosystem. So if you have those kind of use cases where performance is key, then that's where you really wanna see. But if you are starting with a new backend, that's also a good place to start. But where I will use Go for the front end will be things. For instance, if you are building a cross-platform system that has a user input required, right? So think about when you go to Azure or Google or Apple and you say social login, you're taken to that login page that has the view of Facebook, Twitter, or whatever you're using to social login. If you had a system that required a user input, you can build that within your Go application, so it will pop up the same for all the users. But that will be a better use case than trying to build web pages on top of this, right? Now, what I will say is if you are a full stack developer, let me share my screen one more time. if you are a full, I was gonna say full screen developer, full stack developer, what you could use is Pocket-Base. So if you are familiar with Supabase or some of the other base projects that are out there that give you a backend for your application, Pocket-Base is kind of new, but it's super famous in the Go in the Go side of things, where it's all built in. It's a whole backend that has your database, authentication, everything, and it's all a single file. So it's super light. You can deploy it anywhere, to your local host, to your cloud environment, to anywhere you want. And it gives you a whole lot of things, and all you have to do is just build your front end on top of it. So this is something that I learned about last month, and I think it's pretty cool, especially the fact that it's super lightweight. And that's something that you can play with if you are looking for something that's lighter, that's lightweight. It's just as performance as Supabase, if not better, and then gives you that whole backend system ready to go. So all you have to do is just make the connections to your database. It does have a built-in SQLite database, which is super fast. But if you want to have it connect to your own, you can do that as well. So that's one thing that is out there right now, and it's pretty cool.
Awesome, awesome, awesome. I'd like to open the floor to everybody else that's still here and has been sticking around. If you guys happen to have any questions or anything like that, feel free to chime them in. Okay, and what I'll do for that is I'm gonna go ahead and stop the recording right now.